start. All right. Good morning. Happy confidence intervals. It's all making sense now. Why was Sydney asking, what have you covered in stats? Well, data science, whatever. It's the stats component. We actually won't get to confidence intervals. We're supposed to leave it until chapter 12, the way they have it kind of arranged and stuff. But now it's all making sense to me. Should probably have covered confidence intervals before. But I don't have the skills to pivot today. I could wing it, but that'd be hard. So we'll just keep going with the path that we're on. I'm curious to know what it is you're supposed to do for those confidence intervals. Like I said, we will get there, but you're already seeing them. So that's nice. Sounds like you're using the tables. There's T tables, Z tables, F tables, R tables, so many tables. We are just going to use Excel. So because we're cool like that, but not cool enough to pivot. Well, sounds like you already know about confidence intervals. So that's all I could tell you anyways. Let's do a little bit of review. We're going to use this data set called the Lone 50 data set today. I'm just going to steal it from the textbook because they've generated some summaries and some graphs. And so just as a warning here, we're going to do chapter 4 today. And it's the start of part 2, which is called exploratory data analysis. Which we usually just call EDA. So if you hear EDA, it's exploratory data analysis. And usually in any sort of kind of data science reporting world, we spend a lot of time doing exploratory data analysis to figure out what it is that we'll be able to talk about, any preliminary findings that we have, just what do things look like. Yeah. And so, chapter 4, I think is called summarizing categorical variables or something like that. Categorical, let's call it data. In the next chapter, we'll summarize numerical data. So today, we're summarizing categorical data, right? Variables that can be placed in categories. And we saw some summaries last day, right, or last week. There are 2 ways to summarize things, right? I could summarize a variable numerically, right? And so a numerical summary which is usually counts in a table. So we need to be able to not only generate the table, generating the table is relatively easy, but we need to be able to read the table and gather information from the table. Yeah. And we can also do a visual summary, right? So graphs in general. Okay. for us in this course for categorical data, we're going to focus on bar charts or bar graphs, if you prefer. Bar charts or bar graphs, just depends on, or bar plots. I never throw that one in there. Charts, graphs, plots, they're all the same. Okay. And whether you make it 2 words or 1, there's lots of different options, but they all mean the same thing. We've already seen bar charts last week, right? Where we have a bar for each of the categories indicating the count. Okay. So let's see here. Last day, we introduced a data dictionary. Right? We had to create your own data dictionary. I gave you a data set and you had to create your data dictionary. And so here's a version of a data dictionary. What they've done is they've, in the description, they've merged the levels, right? And so I made you highlight if it was a numerical variable or a categorical variable. And so they don't do that here, but that's good kind of practice. All right, so let's start by figuring out, okay, so we've got this lone 50 data set. So there's oh, I can't remember the name of it. There's a loan company, right? I think it might be peer-to-peer lending, but anyways, doesn't matter. And so we have this loan data, okay? These are for kind of smaller amounts, so they're not mortgage loans or anything like that. They're just kind of personal loans. And so, of course, the first thing we have information on is the loan amount. How much did they get a loan for? Okay, in US dollars. I'm going to say that's a numerical variable. We'll save that for chapter 5. Okay. The interest rate in an annual percentage, I'm going to go ahead and say is also a numerical variable, right? If you're kind of waffling, because there will only be a set number of interest rates, right? Then you want to kind of argue, does it make sense to talk about the average interest rate? And to me, it does. And so I'm going to lump it with numerical as well. The term is the length of the loan, which is always set as a whole number of months. You know? So that to me is kind of a clue. I could use those as categories then, right? And so even though it's numerical, I would probably prefer to analyze them as categories, right? And so I'm going to go ahead and say this is categorical. Right, and so treat as categories. I will say in my EDA, snazzy, in my exploratory data analysis, right, one of the things that I would look at first to really decide if I want to treat it as categorical or numerical, right, is look at how many categories there would be, right? If there are 3, 4, 5, that's a good categorical variable, right? And that's probably a good grouping variable that we can use later, okay? So then I would still treat it as categorical. If I have 15, 20, whatever categories, maybe it makes more sense to just treat that as numerical, right? Kind of on a continuous scale. Okay? And so here I will say could be numerical. We have a grade column, okay, which is the loan grade. And then it tells us, because we don't know what a loan grade is, probably, I don't. But it takes the value A through G and represents the quality of the loan and its likelihood of being repaid. And so from here, I would also like to know what a good grade is and what a bad grade is. I assume an A grade is good because that's how we're kind of used to functioning, right? And so, but that's something I would probably like to add to my data dictionary, right? Something to keep in mind if you're making one, right? You don't want to leave any questions. But let's assume an A grade is good, or the best. Right? So this would be a categorical variable, right? And it's got a lot of information built in, right? It's probably built off of other variables, right? But we can summarize it as this grade. Okay? The state, oops, I need my pointer. The state is the state where the borrower resides. Okay? I'm gonna say that's categorical. Don't want to talk about the average state, but also how would you calculate it? I guess if they were all assigned a number. That doesn't make sense. The total income. We know that that's obviously a factor in your loans. Okay? And so the borrower's total income, including any second income in US dollars. I feel like if it's the total income, then yeah, it should include all the income. Definitely the second income, third income, whatever. Numerical. And then the home ownership. Does the person owns but has a mortgage, right? That's going to be a subset. Sorry, we're going to treat those as distinct. Okay? And so if you own without a mortgage is separate from owns with a mortgage, or if they rent their home. So here I'll say no mortgage. This is categorical with 3 categories. Oh yeah, the quiz. I was waffling back and forth all weekend. And then I thought, I'll ask you guys, because we've got 4 quizzes. Should probably get cracking on those, huh? I know when I want to have the quizzes. I want to have a quiz. I'll go back to the. So we're here today in chapter 4. Wait, what? No. Okay, I'll go to Moodle. Hello? I think it just needs to wake up. After chapter 6, I want to have our first quiz. And then I want to have a quiz after each part. So the textbook's broken up into parts, which means we'll have a quiz after regression, lines of best fit, all that fun stuff, scatter plots. Oh no, it's still, uh-oh. Well, I can keep talking. And then after kind of introduction to inference, which includes confidence intervals and hypothesis testing, if those sound familiar. And then another one after the last part where we introduce all these different types of inference. I don't know what that means. Go. Sounds like a knock on the door. Just buying time, I guess. I wonder. Phew. So, my question to you is, do you want an in-class quiz or an out-of-class quiz? Where you just, it's timed, you sit down, you do it on your own, you get one shot, one opportunity. Out of class? I know, cuidado, out of class is gonna have to be harder. So, I know, you can see why I was waffling back and forth. I want to have the in-class time to do all the things I want to do, but I can make room in our schedule, which means we cover less material, which is also kind of nice, I guess. For you guys, not for me. I have goals. No goals. Hey, why isn't it loading? Think about it. Right now I have it scheduled just as an out of class quiz. Okay. I would need to kind of make some tough decisions on what to cut. I've got an idea of what to cut already, so things we don't usually cover anyways. Let's see here. So after chapter 6, which is another application section, but what we could do is we could do a quiz, just a 1-hour quiz, and then do an hour applications where you play around in Excel, and it doesn't really, it's just for fun. And then I can do the same thing-ish. So I just want to do kind of an hour-long quiz, or 50 minutes. That sounds better, right? Way better. Can't really get a read. How about, yeah, everyone's like, how about no quizzes? They're only 10% each. Yeah, right? It's like impending doom, done. You don't have all weekend to put it off and then ruin your Sunday night. And you're on your own. Mm-hmm. Free time. Yeah. How about we do it in class then? I'll readjust the schedule, but so after chapter 6, or kind of, I think what I'll do is I'll do it before chapter 6, because chapter 6 again is just kind of playing around, making bar charts again and that kind of stuff. And so just kind of some notes. Yeah, so that would put it on January 28th. And it would be on chapters 1 through 5. Let's write that down. I've already used pink. I gotta go more pink. No, there is nothing more pink. Quiz number 1 in class, January 28th, and it'll be on chapters 1 through 5. It looks like a bracket. Okay. And it'll just be a 50-minute quiz, then chapter 6. I haven't decided yet. I don't like to make you do Excel under pressure. I don't think that's cool. It's not really how it's supposed to go. Unless you're in a tournament. Right, then you can do Excel under pressure. But that's not really what I'm about. So I'm leaning towards just no closed book, bring calculator, just for kind of a emotional support, I guess. And we'll stick to theory for the quizzes. Okay. We'll see. Like I said, I am changing things up. And so if the first quiz, if after that one you find, oh, I think it would be better if we were just, you know, allowed to use Excel as a calculator or something like that, then we can change it. But for quiz one, because it's mostly theory anyways, let's do completely closed book. Makes it easier to study for, I think. Good. Any questions about that? I reserve the right to potentially have an open book quiz in the future, but open book is hard, right? Because I'm allowed to make it hard. You have resources. Closed book, you know what to expect. It'll also kind of mirror what you'll see on the final exam better as well. And so, because as far as I know, I'm not allowed to have a computer final exam because we're not in a computer lab. Old school. Anyways. Okay, categorical data. So what are some categorical variables? If we focus on, just because I know what they have used in the textbooks, so if we focus on home ownership, that's a categorical variable with how many levels? With 3 levels. And so here, home ownership is a categorical variable with 3 levels. Right? If we do a numerical summary, right, then that's going to be kind of counts in a table, right? And pretty straightforward stuff, right? Each of the levels has some count, and the 3 levels should be exhaustive, right? And so it should cover all your data points. Okay. And it's going to look something like, it jumped me around. So let me just find it. Something like this. One thing about exploratory data analysis to keep in mind, but also reporting data, right? Our brains aren't very good at comparing these numbers. They are out of 10,000, but imagine this was out of 7,321, right? That can happen. And so just imagine for a moment that we have something like this, right? A total, a weird total, and I tell you, oh, 1,353 out of 7,321. Our brains don't do a great job of understanding how big of a proportion that is, right? And so the reason 10,000 is easy is because the proportions are easy to get to, right? And really to compare these values and these groups, then the next step would be to calculate the proportion. Okay? And so I'm gonna remove this because that was just hypothetical. But what I want is bump this up there. And what we're gonna do is, let's make it a proportion or a percentage category. A proportion, we're going to call the number of successes over n. Okay? And so later on, and I'm kind of setting you up for success, a proportion in general is going to be the number of successes over n. Okay. Later, we're going to just call capital X the number of successes over n. Because you don't want to write out the number of successes. Well, it means you have to spell successes. No thanks. But also, you don't want to be writing too much, right? And so we've developed this shorthand notation. We use capital X. I should make it clearly capital here as the number of successes. So if I'm talking about the proportion of people who rent, right, then it would be 3,858 divided by n, which is 10,000. Right? The total is your sample size, right? Everyone fits into one of these categories, which is what we're talking about. And so the proportion here is going to be 0.3858, 0.4789. Oh, I think I'm missing, what happened here? Am I missing a zero probably? No, I'm good. But let me just bring out my support calculator. Let me just check here. 0.1353. These proportions, we could kind of get there on our own, right? But these proportions should add to 1, right? If we've covered all our options, should add to 1. So let me just check here. 0.3858 plus 0.4789 plus 0.1353. Phew. Otherwise, I did something wrong. A proportion is just a percentage, sort of, right? Multiply it by 100 and we get a percent. Right? And so here, I get 38.58%, 47.89%, and 13.53%, which of course should add up to 100%. We use percentages because our brains do a really good job of understanding percentages, right? So a lot of research has been done, and kind of the reason we do the things that we do was because our brains work in certain ways, okay? And we can understand information easily if it's in percentages, right? Okay, so that means that a proportion is roughly a percentage, right? I say approximately equal to a percentage just because you have to multiply by 100, right? But otherwise, they're the same. You can move between them, but also kind of interesting for later is that a probability is a proportion, which you can convert to a percentage. So we've got a random sample of loans, right? Presumably there are more loans than this, right? There's some population of loans. And so what can we do? We could say, well, given this sample proportion, right, of loans that from people who rent their home. Then I can say the probability of finding someone who's getting a loan that rents their home is 38.58%. I know probabilities are proportions, but usually we communicate them as percentages. So we have to stay flexy there. But these three P's all mean roughly the same thing. And so we can use these interchangeably. Right there. We use these interchangeably. Okay. What if I asked you this? Is the distribution of loans across home ownership, is it evenly distributed? Probably not, right? I am looking specifically at the jump from 47 to 13-ish, right? Kind of broad strokes. Okay. So from that, I would say, no, it doesn't look like it's evenly distributed, right? And so we can still figure out what the distribution looks like for a categorical variable, right? Just given this table. Okay. Let's see here. Any questions? No. Not a lot we can do beyond converting to percentages or proportions for the table, which is pretty common that we do. Okay. But other than that, numerical summaries kind of end here. Kind of boring. In terms of our visualizations, we might get something. Fine, I'll keep the labels like this. These look the same, and they are, right? But now we're visualizing or visually summarizing the home ownership variable. So here is a visual summary. Got lots of options. But for one variable, if I'm just looking at one variable, then there's, again, not very much we can do. And these bar charts are just visualizations of the table that we just saw, right? And so what we'll find in Excel is in order to make a bar chart, it needs the table in the background. And so they go hand in hand, right? It's just a graph of the table. Okay. These two look the same, right? It's only the scale that they're on that changes. Okay. Otherwise, they look exactly the same. The proportion graph here is just kind of a shrunk down standardized version of the graph, right? Which means that we could compare it to year over year, right? If we have a different sample size, right? And so the proportion version of the graph is usually more helpful if you're doing kind of year by year comparisons, things like that. But the counts look the same. And so here, the bar graph are, can I say just? I try to not say just because nothing is just do this, just do that. I say that all the time. but nothing is just. And so the bar graphs are just visual versions of the table. Even easier to gather information quickly, right? And so which group had the highest proportion of applicants? People with a mortgage, so they own their home, but they are still paying off their mortgage. And so they're representing the highest proportion in our group, which we could have gathered from the table, right? But in terms of reporting your data, right, if you're trying to keep someone's attention through a report, then graphs are going to be a little bit easier, right? Easier to use. Making someone read a table or tables upon tables upon tables is not that fun, right? So we like to spice things up. And I know what you're thinking, but what about my pie charts? No, 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 no. Pie charts. What color can I use here? I should use red. Oops. Because it's more of a burgundy here. Pie charts could be used. I've got some beef with pie charts. I'll tell you kind of the quick version, but pie charts could be used to visualize categorical variables. But here's my beef. Being able to compare the different slices. So everyone's seen a pie chart, I assume, right? We kind of understand what a pie chart looks like. I'll go snag one here. Kind of rearrange some stuff here. But comparing the slices is a little bit more difficult, or can be more difficult, right? Especially if you have more than 3 categories here. If you're introducing a 4th category, right, or 4th level, 5th level, 6th level, right, the pie chart gets kind of nasty looking. Okay? But it is generally difficult to compare the levels. Which is ultimately our goal, right? Is to be able to compare these levels and compare these groups. Let's say, for example, if I have a bar, another bar, just a pretend bar over here. Right. The difference in those slices, right? You wouldn't be able to tell the difference in those slices, right? But from the bars, and again, a lot of research has gone into it, right? Our eyes do a really good job of even detecting these small differences in the bars, right? Whereas in the pie charts, the slices would look almost the same. And so that's kind of the caution here. Like I said, I have some beef, but that's the main one, right? It gets difficult to compare the levels. Okay. When is a pie chart kind of the most obvious? A pie chart is really only obvious, right, if you only have 2 groups. Right? And so a pie chart is only obvious if we have only if we have only two groups or levels or categories. Might look something like this. Whee. Okay. Let's say this is should have done some math that no. What's the other? If I tell you that the one slice is 63%, the other slice is 37. Okay. Couldn't I just have said, well, in this group, there's 63%. And if there's only two groups, then it implies that you know the other group, right? Probability that you get an A on quiz 1 is 63%. You know the probability of not getting an A, right? Just by getting that number. That's not the probability. It's 100%. No. We never say 100% in stats. Never. So here, right, we can communicate everything with just the one number, or all the information with one number. Right. Probably put a label. So then you don't need a pie chart. The only time that I would maybe be okay with a pie chart is if you're making a dashboard. And so a dashboard is just a kind of a one-page summary of a data set. And it's just to add some interest, right? But just try to avoid it if you can, although I know it's tempting. They look fancier. And then even worse is probably the donut chart. Donut charts are in Excel. What's a donut chart? Well, it's a pie chart, but you just cut out the hole. There, now you've got a donut chart. It's the same. So silly. Anyways, but they are used to add some visual interest, right? If you log into your, I don't know, let's say TELUS account, right? They'll have a summary of all your information, right? This is how much data you've used so far, and this is how many minutes you've used, or whatever it is, right? And so that would be a dashboard. Okay. Good. Any questions? Yeah. Usually we have two categorical variables. So here's one. There's not a lot that we can do with one categorical variable, but usually we want to look at the relationship between two categorical variables. So we often want to analyze the relationship between two categorical variables. Can't remember what the other variable was, so I'm going to go snag it here. I think whether they were joint applicants. Was the joint in my data summary? No. Sneaky. We'll add it. The application type, whether it's a kind of a joint application, so presumably a couple or a couple of friends, versus an individual application. Okay. So here, applying together or applying individually. Pretty self-explanatory, but it's another categorical variable. They did not have it. Chapter 1. That's okay. Can add it to our data dictionary. So now I have two categorical variables. I still have the home ownership, but now I'm introducing that application type. And we want to know if there's a relationship here, potentially. Yeah. Okay. We've got the same 10,000 loans that we're looking at, presumably a random sample from the loans data, right? A representative group of the entire population. Otherwise, what are we doing it all for? Yeah. And so we've got a random sample of 10,000 loans, and 362 of those 10,000 were joint applications from someone who rents their home. Right? 950 were joint application with someone who has a mortgage, and so on and so forth. We're going to have these row totals and column totals, right? Notice that this column total looks familiar, right? That's the same as the table for the home ownership that we saw, right? And so here, these guys, right? This is the home ownership. Oops. Home ownership summary. So we could have done the same thing for the application type. And in general, this type of table is called a contingency table. Yeah. So when we have a table like this, we call it a contingency table. Yeah. Which leads us to contingency analyses. Right? We'll be able to analyze this contingency table, but for now, we just need to be able to read it. Okay. Same as before, right? When we convert it to proportions, or probably more likely percentages, right? We can do the same thing depending on what we use as our total, right? Usually I would recommend using the 10,000 as your total, but it depends on what information you want to gather. And so what if you use your application type totals as your kind of what your fraction is over? Okay. So for example, consider let's say 3,839 out of 8,505. This is going to be a proportion, right? What does this proportion represent? What does this proportion represent? First, you have to find the 3,839 in the table here. So let's write it out. 3,839 over 8,505 is going to be the individual applications who own their home with a mortgage. I'm going to say this is the same as individual and mortgage. I'm not using that and lightly, that's on purpose, right? Because it has to be both of those in order to hit that one overlap. Okay. Divided by, now this 8,505 is the total of individual applications. Question?
Isn't that just Bayes' theorem?
Yeah, we're not gonna get to Bayes' theorem, but yeah. Helps, yeah, helps having taken probability before. Yeah, wait a second, I know the name of this thing. Yes. Here we just say it is this. But this is out of the all individual applications. So when we're focusing on all the individual applications, right, then we call this a conditional probability, right? And so when it's no longer out of this grand total, this, it is called the grand total, right? When it's conditional on what group it is you're considering, right, then we call it a conditional probability. And so here, this is called a conditional probability. So usually what I do is I give you a table like this, and I ask you a series of questions, right? What proportion or what percentage of renters were joint applicants? Okay, let me write that down. What proportion of renters were joint applicants? So now your focus is, okay, well, they have to be renters, right? And so what proportion of the renters were joint applicants? And so now we're focusing up here, right? And so they have to rent. That means they have to be in this column, right? In fact, the total that we're interested in is this 3,858. So I usually like to start with the denominator, right at the bottom. And so the denominator here is all the renters. And that's from what proportion of the renters were joint applicants. Joint. And it's implied if they have to be out of all the renters, then it should be joint and rent. Usually, let's see here. If I ask that question, right, you can look at the table and you don't have to think about what goes in the numerator, what goes in the denominator, right? You can just kind of see it, right? And that's totally fine. Some of these can be kind of finicky. 38, 58. I have an example I want to do. Let's do it. Let's do it. I feel like it's question 2 or 4. I grab them from the odd ones or the even ones here. Question 2. So on the quiz, you can expect, oh no, there I said it. Can expect something like this. And let me crop this up here. Gonna just split it across the pages. This is a contingency table, right? And I need you to be able to read it and grab information from it and find probabilities or percentages or proportions, but those are all the same thing, right? And so fractions from this table. Okay, let me zoom in here as much as I can. 910 randomly sampled registered voters from Tampa, Florida were asked if they thought workers who have illegally entered the US should be 1, allowed to keep their jobs and apply for US citizenship, 2, allowed to keep their jobs as temporary guest workers, but not allowed to apply for US citizenship, or 3, lose their jobs and have to leave the country. Wow, yikes. The results of the survey by political ideology are shown below. And so we've got information on what? We've got a variable on how they vote, right? Which we're kind of calling political ideology, right? Or summarizing as political ideology. And the response on the survey, right? And let me map this out. This was called 1, allowed to keep their jobs. This was 2, leave their country. 3. And then not sure is, well, none of those, but it was an option, right? If you're designing a survey, you should always have a not sure or not applicable column, just so so you don't have any missing data. People felt pretty strongly, I guess. Not sure. Why do I say people felt pretty strongly, right? In the not sure column, there aren't that many, right? Out of 910, only 20 overall were not sure, okay? Of those 20 though, 15 were in the conservative, and I don't know, maybe there's a reason for that. Maybe they were sure, didn't want to say, right? That can happen. That happens a lot with surveys, right? We've got these kind of loaded questions and we don't get true information. Okay, so I've got these two categorical variables, and I should, the results of the survey is in orange. All right. We'll start off. Copy. And I'll bump A up here. What percent of these Tampa, Florida voters identify themselves as conservatives? Now, the first thing you want to do is figure out, okay, what is this fraction out of, right? And so it'll be in the question. So what percent of these Tampa, Florida voters, no worries. Yeah, no, I wish there was a way to unlock it.
I'm trying to see if that if it's pushed from the inside, if we can return from the outside, but we can test it. Let's maybe send somebody out. I'll press it.
Watch this.
Oh, just that way.
Oh.
Can't even beat myself in.
That's crazy.
I know. There. We had a hypothesis. We tested it. We have a conclusion. Yeah. And that's stats. Way more fun than this. I know. I wish. But I think it's like a safety thing. Need to be able to lock the doors. Speaking of Tampa, Florida, or the states in general, I guess. So when you're reading these, and if we read ahead, all right, we're doing A right now. I'll crop that out here. Bink. What percent of the Tampa, Florida voters are in favor of the citizenship option? Okay. What percent of these voters identify themselves as conservatives and are in favor of the citizenship option, right? That's different. Right? And so reading these, they can get quite muddled, right? And so just in general, you want to figure out, okay, what's the total that I'm interested in, right? And so what's going to be in the bottom here? What percent of these Tampa, Florida voters identify themselves as conservatives? So no other restrictions on just all of these voters, okay? Which means that the total is that total 910. Okay. And then what total of those were conservatives, right? Doesn't matter how they responded to the survey. We don't care about that in this question. And so conservatives or self-identified as conservatives, we have 372, which means 372 over 910, which is roughly 0.408791288. Probably keeps going, but that's all I get. Or now here, I'm going to go to 2 decimal places for my percentage, right? You don't want to round your proportion, right? You don't want to be lazy. Right? You should show your full proportion, but it does ask for the percentage. And so 40.88%. Why would I keep all my decimal places? I need to make sure that if I add this conservative total proportion to the liberal proportion to the moderate proportion, that's all my groups. They should add to 1, right? So if you're rounding too quickly, then you're going to lose that property where they add to 1. So they should still add to 1. I mean, the safest thing is to just use the the proportion itself, right? But that's hard to communicate. Okay. So 40.88% of these voters identify as conservatives. Nice. Okay. I'll grab from this as we go. Copy, paste. What percent of these Tampa, Florida voters are in favor of the citizenship option? So now, in my mind, this is the same type of question as I just asked, right? It's just asking for in favor of the citizenship option, which is option 1. The total out of all the voters was 278 over 910. Right, so again, it's out of the same total. Oops. 278 out of 910. I'll do that. 0.305494555 or 30.55%. What would you have to do if you wanted to talk about the distribution of the responses, right? Then what could you do? You could figure out the proportion in favor of option 1 versus the proportion of option 2, option 3, and then the not sures, right? And so then you could compare those percentages, right? Which I think we do later, so, or we do something similar. Oh, sorry. What percent of these Tampa, Florida voters identify themselves as conservatives and are in favor of the citizenship option? Okay. This one's a little trickier, right? And so what percent of these Tampa, Florida voters, okay, so now my total is still going to be all the voters, right? But we want to narrow it down to that identify themselves as conservatives and so they have to be conservative and in favor of the citizenship option, which is going to be just this 57 out of 910. $57 out of 910.0626373624 or 6.26% to 2 decimal places. It's going to take some practice figuring out what the total is. So far, it's been just the grand total every time. But how about, I'm assuming this next one, we won't be so lucky. I am assuming, though, I haven't read it yet. Well, I'll be darned. What percent of these Tampa, Florida voters who identify themselves as conservatives, right? That's going to adjust your total, right, that you're interested in. And so now, so they have to be a voter, obviously, and they have to be conservative, right? That changes your denominator. But we also want to know they're in favor of the citizenship option. Can I call it option 1? Oh, I thought we were going down, but we're going across. What percent of moderates share this view, and what percent of liberals share this view? Yeah. And so here we'll say the conservatives first. So of the conservatives, in favor of the citizenship option. Okay. So I have 372 conservatives, and 57 of those were in favor of the citizenship option, right? So 57 out of 372. What percent of moderates share this view? I'll do the calculations all in one go later. So the moderates, and then we're going to do the same thing for the liberals. Careful, because the moderates are over to the right. And so 120 of 363. And for the liberals, 101 out of 175. I forgot. 175. $57 out of 372. 0.15. 32258.065. 120 divided by 363. 0.33057.85124. And 101 divided by 175. I wish I could have these on the same page. Are these going to add to 1? No, right? I heard it. Right? Because here, I took 57 out of 372, right? 57 out of 372 and 121 out of 372 and 179 out of 372 and 15 out of 372. Those all have to add to 1, right? Because I'm talking about the same group. But now I'm working kind of this way across each respective group, which means that I'll be able to compare these percentages. They should be on the same scale, right? If they're the same, right? And so if there's no relationship between political ideology and how you feel about citizenship, etc., right? Then we would expect these proportions or percentages to be roughly the same, right? So I guess I could do percentages, but if there was no relation, or if there is, I'll say, if there is no relationship between, I don't know, how can I summarize it? Can't, political ideology and opinions on citizenship, we would expect these proportions, right, or percentages, to be roughly the same. We would expect these proportions to be roughly the same. Right? From sampling and from random chance alone, right? They're allowed to be a little bit different, right? But essentially the same. Now, when I look at these, I don't feel in my gut that these are essentially the same, right? I feel that there's quite a large difference looking at my largest one to my smallest one, right? There's quite a large difference knowing that the scale of a proportion goes from 0 to 1, right? That helps. If my scale was from 0 to 100, then no, I wouldn't say that there's a huge difference here, right? So it depends on the scale, right? But we'll be able to incorporate all those things, and we'll be able to do a formal hypothesis test of whether these are essentially the same or not. Okay? And so we'll get there. But for now, just this kind of gut reaction of no, I think there is a relationship there. That's all I'm looking for. Questions about that one though? Okay. That was, hey, looks like I already answered it. I do that a lot, I think. I like Mina's textbooks because she and I think very, very much alike, which helps. But also I've used her textbooks a lot, so I'm kind of familiar with how she does things. There. How about this? Can I just snag this? Whee! There, I already did it. So if there was no relationship, right? But since these proportions are quite different across the groups, right? Then we suspect that there is a relationship. Since the proportions are quite different, quite different across the groups, we suspect there is a relationship. And don't make me say between political ideology and opinions on citizenship. Across the groups, we suspect there is a relationship or an association. A relationship, I'll do / association. We use those two interchangeably. I will, because I mentioned it, notice these proportions will not add to 1. Will not add to 1, right? But they are comparable. But they are comparable, which is nice. Time flies when you're having fun. This next one is not something that I would get you to do on the quiz, but it's good to kind of start thinking about some other variables that could explain this potential relationship between these two variables. Right. Off the top of my head, depends on where you live in the States, how you feel about kind of immigration and things like that. That also impacts how you vote, right? Because kind of groupthink and all that stuff, but so maybe location, maybe even in, hey, I forgot we were only talking about Tampa, Florida. So location's out. What's another one? How about if you yourself are an immigrant? That could probably affect how you feel, right? Yeah, yeah. Something like that. Let's do that. Something like
Socioeconomic.
you guys just keep them coming, huh? Okay. I'm still spelling socioeconomic. Socioeconomic. Business owner? Let's call it there. You guys did great. Maybe I should put something like that on the quiz. You guys are good at that. I'm really bad at it, so that's why I don't like to ask those questions. Right? But thinking about other things that could impact the results, right? That's important. So these could be confounding variables, which I can't remember, but I feel like I've mentioned the word at least once before. So a blocking variable we would have collected, whereas these we don't necessarily have collected. Potential, I'll introduce it here. Confounding variables, right? Things that impact the results but haven't been explicitly collected. Impact or potentially, or impact, so a confounding variable impacts the results. Confounding, I'll clean it up. Nope. Well, that might be worse. So you're welcome. Impact the result or potentially impact the results, but not necessarily collected or even collectible, right? But not necessarily collected or collectible, as opposed to collectible. Able to collect. We could ask them, what's your immigration status? Do you think you're going to get a true response? Another problem, right? So potentially confounding. Some of them will be true, right? I'm a citizen. Some of them might not be. Okay. Good. All right. I got sidetracked, but I wanted to there's other plots, but I don't like them very much. We're going to stick to bar plots. There are a couple of different types of bar plots that you can use. And so here are kind of our go-tos. I'll bring these in here. That's the end of that question. But do you have any questions about that question? Questions about the question? Okay. So these are different types of bar plots. They incorporate two variables, right? And so the first one, right, has, again, the count on the x-axis. Now that total height of the bar is going to be the same as the total in each of these groups, right? And so then I think it might be more helpful. It depends on what you want to report on, right? And so if you want to highlight that, okay, the group with the most applications were in the mortgage group, right? Then this would be the graph for you. Okay. And then we can break it up, the legends down here, but it's the blues are the joint applications and the individuals are the yellow applications. So within each bar, we have broken it up by those two levels. Right? And so this is how we incorporate the two categorical variables into one. Okay? The difference between the first one and the second one is that the next one is standardized, right? So proportion. So if you wanted to just compare the proportion of joint applications across the home ownership categories, right, then this one might be more useful, right? So then your focus, I would say, is on the second variable, kind of the breakup variable. And so it depends on what you want to communicate. Okay. This is all showing the same information as we had in the table, right? It's just a visual representation of what's in the table. Okay. And so finally, we've got this home ownership, and they've been broken up by the joint and the individual, and they're just getting their own stacks, right? Which might be helpful for comparing just overall, but it takes up a lot of space. And so usually that's a reason to avoid it. If you have lots of categories, right, it can take up a lot of space. But again, it just depends on what you want to communicate. Okay. They call it a dodged bar plot. I would probably call it a side-by-side bar plot. I guess side-by-side bar plot. Bar chart or whatever. I'm also kind of wishy-washy on if it's one word or two words. So I kind of write them. They do too, but you can do one. Okay. And so different terms, but Excel would let you play around with each of these, right? And I don't know, it's not my job to tell you which one of these is best. But it is my job to tell you that if you include a graph in your report, you should talk about it, right? And so here, just in general, if you include a graph in a report, it should be to support your statements. So your choice of which of these bar plots to use depends on what your statement is. Okay. And so the choice, oops, the choice of bar plot from above depends on your statement. Takes practice. Okay. So here, I'm interested in mostly the homeownership status. Okay. Let's see if I can. It's too early to stand up. So here, I would be interested in mostly the homeownership status. Whereas here, I would be talking probably about the distribution of the joint versus individual, so the type of application instead. So here we can compare the type of application. And then here, if we want to compare them all on the same scale, right? And so this compares all groups on the same scale, with 3 homeownership status or levels and 2 application types, right? I have 6 groups. Okay, so it compares all 6 groups on the same scale. Okay. So it depends on what you want to talk about. Okay. But other than that, it's just a visual representation of the table, right? Which means in the background in Excel, you're going to need to have the table in order for it to generate the bar charts, right? And it'll be able to offer you all these different types of bars. Okay. Nice. There's mosaic plots. Okay. I don't really like mosaic plots, but a mosaic plot looks like this. Let's focus on this one. It's called a mosaic plot. I don't like them because you might have to explain it to whoever you're presenting the information to, and that defeats the purpose of providing a visual. You shouldn't have to explain it, okay? And so that's something to keep in mind too, right? The width of the bars indicates how much of the sample was in each of the groups, right? And so the own group has a small bar, right? Mortgage group has the largest kind of bar or widest bar, and then the rent bars is the middle of the two, right? Which we know from the proportions, right? And then it's been split up proportionately within the application type. Yeah. And so I will say could be hard to explain. Can we call them shareholders? Usually we call them shareholders. That's your boss or your client or whatever. Whoever you're writing the report for. Me. If you have to write a report for me, I'm the shareholder. Whoever's reading your report. There, put that on your resume. Succinctly summarizes categorical data for shareholders. Ah, nice. Sounds snazzy, I think. Same thing, mosaic plots. We talked about row and column proportions, blah, 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 blah. Talked about pie charts, waffle charts. Now, I will say, maybe I've been out of the loop for too long, but I have not ever used a waffle chart. I'm not even going to bring it in. It is kind of cute, I guess, but feels like you could make it with Lego, right? If you got the right Lego pieces. So they exist, sure, but I'm not gonna talk about waffle charts beyond that. We'll talk about numerical data, right, next day. But one of the ways that we could use these categorical variables is usually to split up these numerical variables, right? And so we can use, there's lots of different plots that I'm holding off on until Thursday, but let's do this. I just want to talk about we can use categorical variables, right? So we've kind of done all we can, summarize one categorical variable, summarize two categorical variables together. We've exhausted everything that we can do, which is kind of fun to think. Well, no, but all the things that we will do. But we can use categorical variables as grouping variables for numerical data, right? Kind of making that extension into numerical data as grouping variables for numerical data. Right. Then we can compare numerical summaries across groups, which means we can compare numerical summaries across groups. There's gain and no gain. We don't know about that. So how about I crop it out? These are groups, but let's call it group 1 and group 2 instead. And we've got some numerical variable in dollars. Monies. Okay. So generically, it's some numerical variable. I don't remember what it's about, but we've got two groups, right? And so in your data set, right, you've got group 1 information, which you can generate kind of a mini spreadsheet for group 1, and then you can generate a mini spreadsheet for group 2, and you can generate these visualizations. Now these are called box plots, which I feel like The box in the middle kind of gives it away once you've heard the term box plots. But these are called side-by-side, side-by-side box plots. So a box plot is something that we use to visualize a numerical variable. It's kind of old school, but it does have the benefit of highlighting outliers. Okay? And so the benefit of box plots is that, and if I let you kind of think about it, you would say, I would ask you, hey, are there any outliers here? Even without me telling you, you would say, yeah, I mean, those dots look different than the rest of the graph, so maybe those are outliers. And that's exactly what they are. So these we've determined are outliers. Yeah? And there are numerical rules that determine those outliers that we may or may not talk about next day. I can't remember. Like I said, it's kind of ancient stuff from when we didn't have software to do all the heavy lifting for us, right? And so then box plots were pretty useful. But for us, we're going to talk about histograms instead, right? We're going to generate histograms to look at the distributions. But if we're interested in outliers, then the box plots are kind of the easiest way to see that. And we can still compare distributions, right? If this is our scale, right? Here's 50, here's 100, presumably 0 somewhere down here, right? Then which group had higher dollar amounts? Group 2, right? They start higher, they end higher, generally just higher. Right? And so even without knowing about the numerical summaries, we can compare those two groups. Right? And so here I'll see, all right, we see the dollar amounts in group 2 are generally higher. Oops. Generally higher than group 1. Right, from here to here versus here to here. A follow-up question that we'll be able to answer eventually is, okay, generally higher. What about, is it significantly higher? Right? That's worth exploring. Okay. So eventually, we will be able to determine if it is significantly higher. Right, if group 2 is significantly higher than group 1. Can kind of use our judgment, right? But we'll have hypothesis testing to compare the two. You could throw it back to confidence intervals, right? And you could compare the confidence intervals. If there's overlap in your confidence intervals, right, then they're not significantly different from each other, right? Usually. I know, usually. Throw that in there. Depends on the spread, right? And that's all. Step away from the plate. There was, I'll throw in the question that I want to start with as review, just briefly here, so that you can try it on your own. It was number 6. Copy. and paste. Try for Thursday. Whee! Number 6. If you have any questions, let me know. Otherwise, I'll see you on Thursday. I'll stop this. Hopefully I remembered to record.